Now, in this video, we're going to take up one more problem, the problem number 17. Calculate the modulus of rigidity and bulk modulus of a cylindrical bar of diameter 25 mm and length 1.6 meters. If the longitudinal strain in the bar during tensile test is 4 times the lateral strain. Also, find the change in volume when the bar is subjected to a hydrostatic pressure of 100 Newton per mm square. Take E equals 1 into 10 to the power of 5 Newton per mm square. So we know the diameter of the bar, which is of 25 mm, and the length is known, and he has given the Young's modulus E 1 into 10 to the power of 5 Newton per mm square. Length is 1.6 meters, which is equal to 1600 mm, and sigma is equal to 400 Newton per mm square. So what is the original volume? Original volume is given by, since it is a cylindrical bar, which is pi d square by 4 into L. So pi by 4 into d square is 25 square into length is 1600. On simplification, you will going to get it as 785,398.16 mm cube. So what is the longitudinal strain? Longitudinal strain is nothing but 4 times the lateral strain. So what is 1 by m? 1 by m is nothing but epsilon lateral by epsilon longitudinal. So we want epsilon lateral. So here epsilon lateral by 4 times the epsilon lateral, because longitudinal strain is given as 4 times the lateral strain. So once you simplify that, you will going to get the Poisson's ratio as 0.25. So then what you need is modulus of rigidity. So modulus of rigidity is given by E is equal to 2g into 1 plus 1 by m. So 1 into 10 to the power of 5 is equal to 2g into 1 plus 1 by m is nothing but 0.25. So modulus of rigidity G is, on simplification, you are going to get it as 0.4 into 10 to the power of 5 Newton per mm square. So now what we are going to find out is, we need to find out the bulk modulus. E is equal to 3k into 1 minus 2 by m. So we know the Young's modulus 1 into 10 to the power of 5 is equal to 3k into 1 minus 2 into 1 by m is 0.25. So k value, on simplification, which you're going to get it as 0.667 into 10 to the power of 5 Newton per mm square. Similarly, what is the change in volume? K is equal to bulk modulus is stress by volumetric strain, which is sigma by epsilon V. So what we know, sigma by delta V by V. So that is V is sigma into V by delta V. So you know the value of K, substitute that 0.667 into 10 to the power of 5. Then we have sigma is 100, which is hydrostatic pressure, which is 100, into volume, which is pi d square by 4 into L, which has been calculated as 785,398.16 divided by delta V. So therefore, change in delta V, change in volume, which is delta V, will be equal to 1178.1 mm cube. So this is how you will be able to find the solution for this problem number 70. Now we will try to continue with the same problem with this another one problem, which is 71. A bar of 20 mm diameter is subjected to a pull of 50 kilonewton. The measured extension of gauge length of 250 mm is 0.12 mm and change in diameter is delta D, which is 0.00375. So what we need to find out on all our elastic constants, which is Young's modulus and Poisson's ratio, bulk modulus and the modulus of rigidity. So to do that, so we know P is equal to 50 into 50 kilonewton, which is 50 into 10 to the power of 3 Newton. So what is the length? Length is nothing but the gauge length, which is 250 mm. So what is delta L? Sorry, D, which is 20 mm. So we have delta L, which is 0.12. Then delta D is 0.00375. So we want to first find out what is Young's modulus. So longitudinal stress sigma is given by P by A. You know the value of P and you know the value of A. So you will going to find out the stress. So that is 50 into 10 to the power of 3 by divided by pi into 20 square by 4, pi d square by 4. So on simplification, you will going to get it as 159.155 mm square. So what is the linear strain? Epsilon will be equal to delta L by L. You know the value of delta L, which is 0.12 by 250. So you're going to get, on substitution, you're going to get 4.8 into 10 to the power of minus 4. Once you get this, so now you can find out what is the Young's modulus, which is stress by strain. So sigma by E. So you know the value of sigma, which is 159.155 divided by 4.8 into 10 to the power of minus 4. So on simplification, you are going to get this as 3.316 into 10 to the power of 5 Newton per mm square. So then we need to find out what is the Poisson's ratio. So Poisson's ratio is nothing but the lateral strain by the longitudinal strain, which is delta D by delta L by L. So on substitution, you will going to get 0.00375, which is the delta D, and D is 20. You know the delta L by L, which you already found out, which is 4.8 into 10 to the power of minus 4, which is equal to 0.3906. So then we comes with the bulk modulus, that is the third condition. E is equal to 3K into 1 minus 2 by M. So you know the value of Young's modulus, which is 3.316 into 10 to the power of 5, which is equal to 3K into 1 minus 2 into 0.3906. So on substituting these values and simplification, so bulk modulus K will be equal to 5.053 into 10 to the power of 5 Newton per mm square. And similarly, we want to find out the modulus of rigidity, which is Young's modulus, which is given by E is equal to 2G into 1 plus 1 by M. So you know the Young's modulus, you 3.316 into 10 to the power of 5, which is equal to G is the one which you need to find out, 2G into 1 plus 0.3906. So on simplification, modulus of rigidity G will be equal to 1.192 into 10 to the power of 5 Newton per m square. So this is how you will be able to find the solution. Thank you.